Hey everybody, we're gonna graph these complex numbers now. It's actually pretty simple, really. I don't think they explain this one part of this, but I'll kind of give you one other extra piece of information here. Bonus learning won't even charge you for. Anyway, we are in lesson 2.4 in Algebra 2, and we're getting real close to the end of the assignment. Excuse me. And in order to graph these, here's how simple this is. See how over here you have your real axis and your imaginary axis, and normally we use the x and the y for those, like here and here. Well, for these, you're doing your a plus bi. So this is your real part. So this is your a number on the x-axis, and your imaginary part b, this is just your b that you're going to graph here. So when it says to plot this -6, we're just going to go straight -6 on the real part, which is going to put that point right over there. The other thing that sometimes they do with these, which just doesn't really show it very well in this example, they'll put these absolute value bars out here, except it's called the magnitude. And all it is really is how far is this point, in this case right there, and it's pretty straightforward here. How far is it from the origin where we started back here at 0, 0? So in this case, it would just be 6. But again, magnitude, how far away is it? Whenever you do magnitude, that's just going to be a positive number. So anyway, this would be a 6, but let's graph that point. Okay. From other examples, usually if you click on the graph, whoops, let's see if I can drag that over to where I wanted it, right there at the -6 on the real axis, and we'll just check that. And then we're going to get the second one. Let me clear the screen here. So now on this one, we're supposed to be graphing the -3 on the real part. So I'm going to come over here, -3, and then -6i. So going down here, this is the I on the Y. So it's going to end up being like right down there. Then we're going to talk about how you do this magnitude thing in case you were to ever run into that. I remember seeing that at least one time on an ACT exam. So since we're right here talking about it anyway, we might as well mention that. I don't think you're going to have it on your assignment here. Okay, so there's my -3 to the left on the real axis. Remember what we're talking about here is like a plus bi. This is the real, and then this is the imaginary part. So when you're doing that, we end up right there. And then let's do the magnitude. So the magnitude, how far you are away from the origin. So in this case, it's talking about this diagonal line, which is just the hypotenuse of this right triangle. So you've got your 3 like on this side, your 6 on this side. So then Pythagorean theorem, 3 squared plus 6 squared, if we call the hypotenuse of that right triangle C, equals C squared. 9 plus 36 would be what, 45, I believe. And then in this case, when you square root it, it would only be the positive because magnitude, these absolute value signs on their magnitude of that. And so what we would end up with here, square root of 45, reminder how you can simplify square roots. 9 times 5 to get the perfect squares out, 3 times the square root of 5. But that's just extra. And hopefully that sort of makes sense in case you would ever see that on one of your exams. That's all there is to it. So that's pretty straightforward, not so bad. But if you've never been shown it, it might be kind of challenging to figure out on your own and look pretty confusing. So good luck, everybody. Just stick with it. Don't give up. You can always come back and watch the video if you need more help. Get really stuck. Bring your question to class. You got this.